All right, so bell work today, an important question, one that you're definitely going to have to do. We had to do this without a calculator. We graphed these two things. That was the key here, is getting that picture. Since there are two different regions where the top line and bottom line change, I need two separate integrals, okay? This first one, that pink one, is this guy right here where we did top line 1 minus x squared minus x. We intersected from 0 to 1. The second one is x squared minus x minus 1 minus x. So the red minus the purple, we're going from 1 to 2. Once you set that up, that's going to be a lot of your points. But if it's not calculator, we got to be able to do this by hand. Your test on Friday is going to be non-calculator, or is going to be calculator, but there is one question where I'm going to make you do the whole integral. Okay, so make sure that you can do that. There's a reason why we're going through this problem right now. Okay, so we're going to go ahead and find the antiderivative. So we can distribute that negative. If I distribute that negative, it's minus x squared plus x. So what's going to happen with my x's? They cancel because I got minus 1 plus 1. So then we can find the antiderivative here. Okay, if we're finding the antiderivative, Max, what's the antiderivative of 1 going to get me? Antiderivative. Yep, 1x, good. And then here I'm going to add 1 to my exponent, so my new exponent is going to be 3, and then divide by my new exponent 1/3. Makes sense on how we set that thing up. That's my antiderivative. Then we just got to plug in 0 and 1. You plug in 1, you get 1 minus 1/3. You plug in 0, and it gets you 0. That's the that's the area of my first shape. Questions on the first one? We're going to do the same thing on the second one. Distribute the negative. So it's going to be the antiderivative from 1 to 2 of x squared. I'm going to get negative x, and this is going to become a plus x here. So those two things are going to cancel, and then it's going to be minus 1. We're finding the antiderivative. We divide by my new exponent. We add 1 to my exponent. We're evaluating that thing from 1 to 2. We plug in our bounds. And then I plug in 1. You got to throw that whole thing in parentheses. You are taking this plus that. That is going to be my answer. Leave it just like that if it's free response. Okay, if you actually did the math, your answer should have been 2. Okay, because I got a whole bunch of different things going on there. It's 1 minus 1/3 plus 8/3 minus 2 minus 1/3 plus 1. 8/3 minus 1/3 is 7/3. 6/3. That's 2 plus 1 minus 2 plus 1. It gets me 2. Questions on something there? An important question, a weird one. You got to graph it. Not my favorite one. I think that's a pretty mean area question, but we got to be able to do that. All right, today we are working on free response. Okay, so I just gave you a packet. This is a couple questions from the last few years, kind of jumping around a few. We're going to start off here on the back side. The 2009 free response question. Okay, this question, 2009, it is AB question number 4. So we'll do this all the time, but there are 6 questions in free response. The first 2 always are calculator. So if I give you a free response question and it says number 1 or number 2, it's calculator. If I give you a question that's 3, 4, 5, or 6, it's non-calculator. This is number 4. That's why it's non-calculator. Okay. The average score on this one in 2009 was a 4.07. That's really high. All right. 4.07 is high. Anything above about a 3.3 is a really high score. So this one, in theory, is easier. We'll see how easy it is for us, but let's look. Each question is worth 3 points. Let R be the region in the first quadrant bounded by y equals 2x. That's that top line. Y equals x squared. Find the area of R. It is non-calculator. Go ahead and find that area. Set it up. Talk with your neighbor. Get an answer. Go. Think about it. It takes some time. Here we go. Let R be the region in the first quadrant bounded by y equals 2x. And that, we're trying to find the area. How do you find area? Well, you integrate. Okay. We could make it a dy problem if you really wanted to, but nobody wants to do that. Everything's written in terms of x, so leave it in terms of x. We're going to go this way. It is a dx question. Show me with your fingers, what are your bounds? Your bounds are x values, so we're going 0 to 2. We're finding area, so we go top minus bottom. My top is 2x. My bottom is x squared. Boom. There's my setup. Everybody good to that point? That scores me a point. If you wrote that integral, that got you 1. Okay. My next point is going to come from finding the antiderivative. So we add 1 to my exponent. We divide by my new exponent. We add 1 to my exponent. We divide by my new exponent. and I'm evaluating that thing from 0 to 2. That scores you a second point. If you just wrote this part right here, the antiderivative correctly, that gets you a second point. I plugged in 2. The good news, what happens when I plug in 0? I get 0. Boom, that's my answer. All I have to do is get that right there. If we could simplify, it would get me 4 minus 8 thirds. At 4 minus 8 thirds, that's like 12 thirds minus 8 thirds. It gets me 4 thirds. That's my answer. Yes, sir.
So if you left just x squared minus 1/3 x
No.
third power, that wouldn't be x?
No, you have to. You can't leave x in your problem. You got to plug in that number. So you got to plug in the 2. You've got to get to. This is my third point. 1 point for 1 point here. 1 point for the yellow. 1 point for the blue. Questions here? Count your points up because I want you to keep total as you go. There's 3. Okay. Next one. The region R is the base of a solid. For this solid at each x, the cross section perpendicular to the x-axis has an area of that right there. Find the volume of the solid. See what you can do with that. To me, this is the toughest part of this question. You're probably realistically only going to get 1 out of the 3 points here, and that's okay. Get the 1 point, though. We're finding volume. How do we find volume? What do we need to do? Integrate area. There's a reason why I say that every time for this problem right here. That's why I say that. I integrate the area. We are going perpendicular to the x-axis. So if we're going perpendicular to the x-axis, is it a dx or a dy problem? It is dx. All right, so it's this region right here. My bounds are going to be the same. It's still 0 to 2. And then I need to integrate the area. Okay, so we have to think, is it a disk? Is it a washer? Is it a square? Is it a circle? Is it a triangle? Which one is it this time? The answer is that. They didn't tell me a fun shape. It's cool when they tell me a fun shape. I have to use it, but this one's even easier. It doesn't always have to be a shape. Sometimes it's just that. That's my answer. So where area is right there, I'm just going to write in the area formula. Sine of pi over 2x. That right there scores me 1 point. If you wrote that integral, that scored you 1. It's weird that we're not, hey, is it a disk or a washer? Well, we didn't revolve it, so it's not a disk or a washer. Okay, and they didn't tell me square, triangle, anything else. They just told me an equation. So all I had to do was plug in that equation. Good so far? And then we got to do the antiderivative. That's where this one gets a little bit tougher. I'm finding the antiderivative sine. What comes before sine? Negative cosine. We would rewrite the baby, and then I need to divide by the derivative of the baby. This is a mental u sub question. Since the derivative of u is a constant, I can just divide by the derivative of the baby. What is the derivative of this thing right here? Pi. The derivative of that is pi over 2, right? It's just pi over 2. So if I'm dividing by pi over 2, I'm really multiplying by 2 over pi. That right there is the antiderivative. We are going to spend time as we get ready for the AP exam. I have it written down over here. We're going to take one day where we just do that nonstop. Okay, we're going to do 60 minutes of us doing mental u sub so we can get better at that. But that's something we're going to do. Everybody with me to this point? I need to evaluate that thing from 0 to 2. So that scored me a second point. If you wrote right here what's in yellow, that scored you your second point. The third point is just plugging it in. So it's negative 2 over pi cosine pi over 2 times 2 minus negative 2 over pi cosine pi over 2 times 0. There's my setup. Okay, we could actually do that math if we wanted to. You wouldn't need to. You could leave it just like that and get full credit. Okay, if I were to simplify that, it's negative 2 over pi. That would get me negative 1 because it would get me pi. It's times negative 1. And then it's minus. This is going to get me 1. So minus a negative 2 over pi. Plus, 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 plus. It's 4 over pi. You don't because it's all one part. There was nothing being added or subtracted there, so the parentheses aren't going to be important, but you'll never be hurt if you throw parentheses there. Questions there? 1 point for the blue, 1 point for the yellow, and then 1 point for the plugging in, which would be this right here, which you could simplify to 4 over pi, or you could just leave it. That one's the tough part. We good? I would say the third one might be the easiest part if you know what you're doing. Find another solid. that has the same base r. For this solid, the cross sections are perpendicular to the y-axis, and you got squares. And then our favorite phrase, write but do not evaluate. An integral for the volume of the solid. That makes this problem a lot easier. See what you can do. All right, we are writing but not evaluating the volume of a solid. Cool. As soon as I read the phrase, volume of a solid, how do we find volume? By integrating the area. We are going perpendicular to the y-axis. So if I'm perpendicular to the y-axis, is this a dx or a dy problem? dy, I'm drawing horizontal lines. I'm going this way across my graph, right to left, right to left, right to left. What are my bounds going to be? 0 to 4. You score 1 point if you wrote that right there on your paper. Okay? You got 1 point if you wrote 0 to 4 dy and dy on. And this is like the easiest points. There's one. My second point is I'm integrating area. Okay? What do I need to integrate? Or I'm integrate my area. What's my shape here? Square. What's the formula for area of a square? Side squared. If you wrote that right there, you got a second point. Side squared. Okay, so something squared. Then all I have to do is plug in my side. From where to where do I make my side? Right to left. So x squared minus 2x. Would I write x squared minus 2x in there? No, I would not, because it's a dy problem. So I need to solve this thing. If I want to solve this one, I just got to square root. If I want to solve that one, I just need to divide by 2. So all I need to write is the square root of y minus 1/2 y. That right there is going to score me my third point on this problem. So that one's the easiest one to score points on. You got 2 points for your integrand and then 1 point for your limits, your bounds here. I don't know why they call it limits. It's definitely bounds. Show me with your fingers all together. Calculating the whole thing. How many points did you score all together without me helping you? Yeah, you can see why this one was the national average was like a 4. And you might not have gotten a 4. That doesn't mean you're not good at this. It just means you weren't good the first time you did it. Okay, it's an average. If you did enough of them, you would average at least a 4. Okay, just on that one you didn't. Okay, be able to set it up. Don't be scared when they're set up this way. You just got to approach it. Okay, let's go to number 2. So go back one page. Okay, we're on page number 3 now. We're looking at this shape right here. This is 2012. It's AB number 2. So if it's question number 2, is it calculator or not? Calculator. It is a calculator question. This time the average was only a 3. So this is a full point less on this question. Maybe harder, maybe not. The last part is pretty hard. I want you to do parts A and B. Okay? See what you can do with that without me helping you. You can work with your neighbor if you need to, but see what you can do on those two. Go. Let R be the region in the first quadrant bounded by those two lines. So obviously this is natural log of x because it's got that natural log graph. And this thing right here is 5 minus x. Did anybody do this first problem? We're finding the area. Did anyone go dy on that first problem? You can. dy is perfectly good here. You would get the same answer. Why, Dylan, did you pick dy here?
I didn't want to make 2 different integrals.
Yeah. If you go dy here, it's going to be the same line on right and left each time. So you're only going to have to set up one integral. It's going to be annoying because you got to solve for y and do some things a little bit differently. But it totally works. I'm guessing most of us did dx. If you did dx, you got to do 2 integrals. Because from here to here, it's one line on top. And then starting right there, we get a second one. Either way works. I'm going to do the other way, but I'll show you the answer here in the end. So my first integral, okay, we're doing dx because I'm drawing perpendicular to the x-axis. That's going to be my first integral. And then this guy's going to be my second one. That first one, we're going from 1 to a. You need to figure out what a is and write it down. You can't just say a without a number. It's 3.63 something. Good. Okay, I'm going top to bottom. So top to bottom here would be easy. It's just natural log of x minus 0. That is that one. Plus my second integral. Now my second integral, I'm going from a to 5. And I'm going top to bottom. So it'd be 5 minus x minus 0. Those are my 2 integrals that I would need to set up. If you wrote that down, you scored 2 points. You got a third point for your value. So 1 point for the integrand, 1 point for the limit. I don't know why they called this. What year is this that they're calling it the limit? 2012. Now they call it the bounds because that's what they are. But there we go. So 1 point for the integrand, 1 point for the bounds. If you did dy, you would have used that 1.306 number because you want to use the y value. If you're doing x's, you'd use that 3.693. Okay? So those that did dy, you'd have that guy. Those that did dx, you'd get that point. 1 for the integrand, 1 for the bounds, 1 for their answer. Most of us got 3 there. Questions on that? Good. Second one. Everything's the same. Okay? The R is still the base. Now our solids are perpendicular to the x-axis, and we got squares. Okay? We're trying to find right but not evaluate the volume. The answer to this question is exactly like this one. The only difference is we've got squares. So for this first part, we go top to bottom, but the cross section is, the areas are squares, so it's side squared. My second integral, we're going top to bottom. It's side squared. Done. That is all you had to write. Okay, so if you understood that, it became a lot easier. You got 1 point for the first one, 1 point for the second one, and then 1 point if you put a plus sign in between. 3 easy points there if you understood what was going on. We're up to 6. The national average was 3. We're trying to score 3 to 4 each time to get a passing grade. Okay, and right now, hopefully we're at 6. Then we get to the last one. This is the one that you're going to need help on. That's why I put it on here today. Okay, pay attention to this one. The horizontal line, y equals k, divides R into 2 regions. Show me with your arm, what does a horizontal line look like? It is that horizontal line. We are drawing a line that is going to split this guy up. There's some letter k that when I split it up, the first part and the second part are going to be equal to each other. I need to figure out an equation that tells me k. Anybody got an idea on how we can do that? K is going to be a bound. Good. If k is a bound, think about that. If k is a bound, is it going to be an x dx problem or a dy problem? Dy, because k is a y value. This is a dy problem. K is going to be my upper bound. What's my lower bound going to be? 0. I'm going to write an integral that is going to tell me the area of the bottom of this thing. So I'm going to find the area of the bottom of this shape right here. So from 0 to k, it's dy, so I have to go right to left. And now I have to write it in terms of y. So if I'm going right to left, 5 minus x equals y. Oh, it's going to be 5 minus y equals x when I solve it. This other guy's natural log of x. What am I going to do in order to get x by itself? E, raise both sides to a base of e. So my equation is going to be 5 minus y minus e to the y. You got 1 point if you got your bounds correct, 0 to k dy. You got 1 point if you did this. This is the right side minus the left side. It says write an equation. So if it says write an equation sign, what else do I need to put in this thing? An equal sign. That seems silly, but sometimes kids get kind of lost. Put an equal sign. What is that going to be equal to? Half of the area. So the easiest way to write that is 1/2 of what I got on part A, 2.986. You could have set up a whole bunch of integrals there instead. Just writing 1/2 of 2.986 would work as well. Yes, sir. Sure, if you put a 2 on the other side, yeah, there's a lot of different right equations. That to me is the easiest. You got a third point here if you wrote some sort of equals expression at the end. Show me with your fingers, how many total points did you score on that thing? The national average was 4. And so a lot of the fingers I'm seeing are higher than 4. Okay? Or I'm sorry, the national average was 3. So anything above 3, that means we're on pace to pass. Okay? And we're going to knock the multiple choice out of the park. Okay? So keep getting better with these, getting ready for Friday or Thursday's test. That way we can be ready to go overall.